Assalamualaikum and a very good day to everyone. We are from Group K16, going to present our final year design project. So our group member includes Mr. Tushran Anak Laki Ragunathon, Mr. Azizi bin Salim, Mr. Muhammad Hanif bin Zakaria, Ms. Nur Afida binti Abu Sama, and Ms. Nur Afikah binti Syamsul Amran. So our supervisor throughout this project is IR Dr. Shuaida Harun, Prof. IR Dr. Zahira Yaakob, Mrs. Nur Hidayah Hussein from Petronas GTS, and Mrs. Dansri Anim Abdul Halim from Petronas GTS. So our title for our project is Utilization of Oil Palm Frond in Production of Gluconic Acid for Non-Alcoholic Based Hand Sanitizer. Okay, so the product that we are going to produce is the gluconic acid with empirical formula C6H12O7 with molar mass of 196.16 gram per mole. So the appearance of gluconic acid is it is a colorless or white crystal, and the melting point of gluconic acid is at 131 degrees Celsius with water solubility at 316 gram per liter. So the application and usage of gluconic acid is it involved in pharmaceutical and food industry. So the advantage of gluconic acid as a sanitizer product is it has an antiviral properties, and high purity gluconic acid is used as active ingredient with chemical compound chlorhexidine to form chlorhexidine gluconate.
Generally, we update our PFD and PNID of the process based on the comment, and we put some improvement on the informations about our product in the report. The plant operated for 360 days per year and 24 hours production time. In 2030, the demand of gluconic acid is about 40,041 kiloton per year and supply is 1,860 kiloton per year. The deficiency is about 2,018 kiloton per year. We decide to cover around 2.3% of the global deficiency of the gluconic acid. Therefore, our plant capacity of gluconic acid is around 50 kiloton per year. The graph shows the supply and demand of gluconic acid from year 2016 until 2022. We decide that the supply and demand of the we can see that the supply and demand of the product is increases over year, where we can conclude that the gluconic acid is one of the important material in the industry. Our main objective of this project is to produce gluconic acid from OPF. The raw materials that use are ammonia, oxygen, sulfuric acid, water, cellulose enzyme, bacteria, aniger, and OPF. The reaction that take place in the process is acid pretreatment, enzymatic hydrolysis, and also finally the main reaction to produce the gluconic acid. After undergoes this reaction, it will produce our main product, gluconic acid, the byproduct carbon dioxide, black liquid, and also water and biomass.
Next is the summary of conceptual design for the reactors and separation unit. So as we can see from the table, this is our reactors and separation unit in our plant. This and the dimension and also the operating cost of each unit. Next is the block diagram for the summary of conceptual design. The OPF and firstly the OPF and other raw material will undergo the OPF pretreatment process, and it will go to the conceptual design level 3, which is our reactor, the seed fermenter and main fermenter. Then it will go to the conceptual design level 4, which is our separation units, the rotary filter, crystallizer, centrifuge and dryer, to produce our main product, which is the gluconic acid.
This is a process flow diagram for our process, which is the production of gluconic acid from asparagine niger. Main reactions of this process happen at main fermenter and seed fermenter. For the reaction at seed fermenter, sterilization must be applied to avoid any contamination to the medium. Glucose powder, water and nutrients are reacted in steam seed fermenter. The main function of seed fermenter is to increase the concentration and population of asparagine niger before entering the main fermenter for the production of gluconic acid. Compositions of the seed fermenter medium is in raw material preparations. For reaction in main fermenter, the pH of the main fermenter is controlled to ensure the suitable pH for the asparagus niger to grow and the production of gluconic acid. This is to avoid the fluctuation in pH which will affect the survival of asparagus niger and the production of gluconic acid. Heat cascade is the value of the heat load will be iterated until value of 0 is achieved. The 0 value indicates that is respective interval temperature is the pinch point or pinch temperature. This is our process flow diagram after we have conducted the heat integrations.
For the instrumentation of process control summary, so the equipment involved is the seed fermenter SF101, the main fermenter MF102, storage tank T101, reactor, centrifuge, dryer and hammer mill. The next is the piping and instrumentation diagram before the hazard analysis has been done.
Next, proceed to the process safety part. For the hazard source in our chemical plant, such as the chemical substance, which are the sulfuric acid, calcium carbonate, ammonia solution and also the gluconic acid, the transmission path is through the active hazard, the thermal radiation and wind dispersion transmission. The receptors are workers and equipment. The physical barrier is label alarm and also a suitable PPE. And for non-physical barrier is maintenance and emergency response plan. For the hazard analysis study, the table shows the summary of some of our main unit in our production plant. Next, this the PNID of our production plant after the hazard analysis.
For the mechanical and the detailed design of the main fermenter MF102, the stream involved for MF102 is stream 1, 2, 4, 26, 27, 29, 18B and 30. So the operating temperature for every stream is between 25 to 28 degrees Celsius, and the pressure from each stream is between 1 bar to 1.4 bar. And the total flow rate for, and the table below show the total flow rate for each stream and the flow rate for each component. And for the design calculation of the main fermenter MF102, so the volume of the fermenter is at 22.52 meter cube. The working volume of the main fermenter is at 17 meter cube. The diameter of the main fermenter is at 4 meter with height of 1.8 meter. So the operating pressure designed for this main fermenter is at 2 bar, and the max allowable working pressure is at 3.95 bar, and the operating temperature for this main fermenter is at 37 degrees Celsius with minimum wall thickness of 8 mm, and the pressure drop for this main fermenter is at 0.35 bar. And for the properties of the impeller, so the type of impeller used is the Rushton impeller. So the diameter of the impeller is at 1.33 meter. The height of impeller is at 0.6 meter. The height above the vessel floor is 0.6 meter above the vessel floor. And the depth of impeller in the vessel is 1.8 meter. The width of the impeller is 0.36 meter. And length of impeller width is 0.35 meter. And diameter of the impeller base is 0.92 meter. The baffle width is 0.15 meter, and the thickness of the disc is at 0.05 meter. And next is the mechanical drawing of the main fermenter MF102.
Centrifuge is selected for the production of gluconic acid with the function to separate the gluconic acid crystal from the solution after the crystallization process. This process occurs at the temperature of 25 degrees Celsius at pressure of 1.1 bar. The inlet stream 33 is composed of the crystallized gluconic acid. The outlet stream of 35 contains the liquid component, which is water, and the outlet stream of 34 contains the solid gluconic acid. The material selected is stainless steel type 304. The vessel height is 10 meter with the conical top height is 3 meter and the cylindrical shell is around 7 meter. The wall thickness of the equipment is around 10.89 millimeter. Based on the value of the longitudinal stress, circumferential stress, direct stress and also bending stress, we can calculate the value of the maximum allowable stress intensity. The centrifuge is safe as the value of the maximum allowable stress, which is 14.1, is lower than the design stress, which is 117.8. The maximum allowable compressive stress of the centrifuge, which is 1.16, is lower than the critical buckling stress, which is 43.47. So the centrifuge is safe and stable. The unit used the bracket support with the welding net flange joint. So this is the detailed drawing of the centrifuge. C101 included the detail of main equipment, detail of brackets and also detail of the flange. The table below shows the dimension of the welding net flange.
I would like to talk about the reactor R102, which is also known as the hydrolytic reactor of continuous stirred tank reactor. The detailed design for the tank is as follows. So, the hydrolytic reactor is used in the gluconic acid production plant for hydrolysis reaction of cellulose, which is to allow the reaction to occur. CSTR is a better choice as the reaction is a multi-phase reaction that involves liquid and solid. The operating condition is at 50 to 100 degrees Celsius and 1 atmospheric pressure. CSTR system is a very well mixed system where cellulose is transported into the reactor using pipeline followed by water, which acts as a reactant together with acromium cellulase as the catalyst of the reaction. For the impeller design, the diameter is 1.1385 meter and the total number of baffles is 4. The number of blade is 16 and the blade length is 0.5692 meter. The type of shell used is cylindrical shell, whereas the head is 3 to 1 ellipsoidal head. The impeller is a pitch blade impeller, whereas the baffle used is standard baffle. The type of material used is stainless steel based on the grade of 304 and a carbon steel of grade 65. The design temperature is 60 degrees Celsius and the design pressure is 1.1 bar. The vessel height is 10.2461 meter and the vessel inner diameter is 3.4154 meter. The shell thickness is 11 mm and the corrosion allowance is 4 mm. This is the mechanical drawing which was designed by me. The design consists of a CSTR hydrolysis reactor with the following measurements.
Next is the detailed design of agitated vessel. The operating temperature is 28 degrees Celsius. The operating pressure is 1.1 bar. The MAWP of the vessel is 86.06 psi. The material is stainless steel type 316L. The diameter of internal vessel is 0.8. The vessel height is 2 meter with ellipsoidal top height is 0.2 and ellipsoidal bottom height is 0.2 also. The longitudinal stress is 9.66. The circumferential stress is 19.31. The direct stress is 0.29. The bending stress is 0.48. The torsional shear stress is 0. The total longitudinal stress of upwind is 9.84. The total longitudinal stress of downwind is 8.88. The maximum allowable stress intensity is 10.44, which is safe, and also the maximum allowable compressive stress is 0.78, which is considered also safe. And lastly, the type of flange joint is welding net flange. So this is my mechanical drawing of the agitated vessel.
Next, we move on to the next part, which is detail design for heat exchanger E02. Heat exchanger is a system used to transfer heat between two or more fluids. Heat exchanger are used in both cooling and heating process. This is because this type of heat exchanger is able to provide a large surface area for a small volume. The type of heat exchanger used is shell and tube heat exchanger. In addition to that, a shell and tube heat exchanger can be cleaned and repaired easily, as it can be dismantled and assembled and without difficulties. Operating condition for E2 at 50 degrees Celsius. In the slide shows there is a block diagram for a heat exchanger. Next is design specification for heat exchanger E02. The outer diameter of tube side is equal to 20 mm. Inner diameter is equal to 16 meter. The length of tube is equal to 4.83 meter. Number of tube obtained from the calculation is 120 tubes, and pressure drop at tube side is equal to 26.83 kPa. For shell side of the heat exchanger, type of shell is shell and tube heat exchanger. Shell diameter is equal to 380 mm. Buffer spacing is equal to 76 mm, and pressure drop at shell side is equal to 29.03 kPa. Besides that, operating temperature for heat exchanger is equal to 50 degrees Celsius. Bending stress is equal to 0. This is because the heat exchanger is in horizontal positions and not considered tall. There is assumed to be no wind load. Stress analysis obtained from the calculation is equal to 27.04. Is less than 75.15. Therefore, the design is safe. Type of flank used is welding neck flank. Next slide is mechanical drawing for heat exchanger. From this slide, we can see that there is a detailed view of saddle support. Saddle support must be designed to withstand the load resulted from the depth of the vessel, as well as the content in the vessel, and followed by the detailed view of side and cross-sectional area of welding neck flank.
I would like to talk about the waste management of our production plant. As for the waste produced, liquid waste, which is also known as wastewater, solid waste, calcium sulfate, and another type of liquid waste is also sulfuric acid waste. Biomass and black liquor are also the solid and liquid waste produced, and the carbon dioxide is the type of gas waste produced in this plant. The selected location is Kampung Pulau Manis, Gambang, Pahang, which is inland water, and therefore the standard based on the Industrial Effluent Regulation 2009 is Standard B. The reduction process shows a proper efficiency of up to 70% in the secondary clarifier. The final biological oxygen demand BOD value is 46.62 and the final COD value is 133.19, whereas the total suspended particles is 73.78 based on the Standard B regulations. This is the process flow diagram of the wastewater treatment plant for our production process. As for the plant layout, the exit provided was an emergency exit and a proper emergency assembly point. We have also separated the section for the plant process, and the direction of the prevailing wind affects our production process. The easy pathway for heavy vehicles to transport goods are also shown in the figure.
We proceed to the next slide, which is economic analysis. Our plant design life is 20 years and capacity productions of gluconic acid in year 2021 is equal to 100% productions. Total capital investment obtained from our project is equal to 83.81 million. Besides that, value for cost of manufacturing is equal to 15.82 million. General expenses equal to 1.67 million, and value for total product cost TPC is obtained from the additions of cost of manufacturing plus general expenses, and it is equal to 1.67 million, and the depreciation is equal to 7.81 million. Next slide is summary of profitable analysis. The value of return investment obtained from the project is 17%. The value is higher than MAR. thus the project is profitable. The value of MAR is 12%. Value for payback period PBP is equal to 4.7. It is less than PBREF, thus the project is considerable. For value of net return is equal to 432.29 million. The value obtained is positive value, thus the project is profitable. Next value is discounted cash flow rate of return, DCFRR. The value of interest rate is equal to 0.18. The interest rate is greater than MER. The project is attractive. For selling price of gluconic acid is equal to RM43 per kilogram. With 25% of profit margin, it is considered a profitable price.
The table shows the price analysis of our product, which is gluconic acid. We decide to sell our product for RM43 per kg with the profit margin of 25%. The graph shows the break-even analysis. The component included in the graph is the value of revenue, expenditure, and also the profit value. Based on the graph, we can conclude that the profitability is higher if the value of the revenue increases with the value of expenditure.
For the conclusion of our production process, it is known as gluconic acid acts as a microbial agent in hand sanitizer and as a component for reaction with chlorhexidine to form chlorhexidine gluconate. Our plant capacity is 50.17 kiloton per year, or equivalent to 5,800 kg per hour. The plant location is at Batu Enam, Jalan Bandar Gambang 1, Kampung Pulau Manis, Gambang, Pahang. The site size is 11 acre and the raw materials are dilute sulfuric acid, Aspergillus niger, OPF, also known as Oil Palm Frond, and water. The process consists of four main processes, which is pre-treatment, hydrolysis, fermentation, and purification. The total glucose conversion is 80%. 50.05% of energy has been recovered from utilities excess energy, and the control system has been designed and to be installed to the plant. As for the legal requirement, chemical and physical hazards were identified and control measures has been taken. Before wastewater treatment plant, the total BOD and COD were very much higher, and therefore, after wastewater treatment plant, the BOD and COD values were within the range. Finally, in economic analysis, the return of investment is estimated at 17% per year. Meanwhile, the discounted cash flow rate of return of DCFRR is 0.17. Thank you.